Hello everyone. So we will wait for some 5 minutes. If somebody wants to join, then they will join. After that, we will start the class. So, okay. Hi everyone. So, this is class 11th class. So, in this class, we will discuss about the assignment number 11th. So, I am going to share my screen in which you will see some of the questions involved in assignment number 12, sorry, 11. So, this is your second last TA class. So, after that, we will meet in the next class, that will be the last class. So after that, you have to appear for the exam for this course. So so today we will discuss this second last assignment, that is assignment number 11. So I'm going to share my screen. Okay, so I hope the screen is visible to you. So um, so this is week 11th class, so I am going to put it on full screen. Okay, so first we will move to the first question. So that LNA has dash and dash sugar structure. So do you know what is LNA?
It's lock nucleic acid. Hello. Hello.
Okay, so the LNA is so if you will see, LNA is locked nucleic acids. So the full form of LNA is locked nucleic acids. Okay, so the name itself is telling locked, so it means it will be rigid. So name is telling locked, so it is having a rigid and locked sugar structure. Obviously, the name itself is telling, if you have see locked nucleic acid, so locked will be rigid. Lock is always rigid. It is not loose, and also it will not be opened. It will be locked structure. So LNA has rigid and locked sugar structure. So the option C is the right option. So this is the locked nucleic acid. So LN is a locked nucleic acid. It is a modified RNA nucleotide that contains a bicyclic furanose unit. So this is one cycle and this is the other cycle. So it is bicyclic furanose unit. So this is a modified RNA nucleotide that contains a bicyclic furanose unit, and it is also known as bridged nucleic acid because this methylene unit is bridged and it is inaccessible RNA. So it is a rigid and it has locked furanose type sugar structure. So the option C is the right option. You can note down.
Hello.
Okay, so moving to the next question, that is second question. So we have to tell which of the following statement is correct. It can be one or two statements, or it can be all. So you have to tell me which of the following statement is correct. So the first option is in LNA, 2-O and 4-C atoms of the ribose are joined through a methylene bridge. The first option is in LNA, like locked nucleic acid, 2-O and 4-C atoms of the ribose are joined through a methylene bridge. Second option is LNA cannot be inserted into RNA. Third option is LNA are very flexible. And the fourth option is none of the above. So as I showed you in the first so this is a locked nucleic acid. So this is a locked nucleic acid. So if you will see, that is one carbon, two carbon. So ठीक है. So the 2-O, so this is the oxygen 2-O, and this is third, and this is fourth. If you will see, 2-O is joined to the 4- carbon atom of the ribose through a methylene bridge. Methylene is what? CH2 group, we will call it as methylene. So this is CH2 group. So CH2 group is methylene. So this is methylene bridge. So in locked nucleic acid, 2-O and 4-C atoms of the ribose are joined through a methylene bridge. It means the first option is the correct option. LNA cannot be inserted into RNA. This is false. LNA can be inserted into RNA. So this is not a correct statement. LNA are very flexible. In first question only we have seen that they are not flexible. They are having rigid structure. So this is also not correct. This is wrong. This is wrong. Because these two are wrong. So this is also wrong. So the only one option, option A, is the correct option. That is that in locked nucleic acid, 2-O and 4-C atom of the ribose are joined through a methylene bridge. Okay, so moving to the next question. The next question is which of the following glycosidic linkage is found in maltose? So the option A is glucose beta 1 to 4 glucose, galactose beta 1 to 4 galactose, glucose alpha 1 to 4 glucose, and glucose alpha 1 to 2 beta fructose. Okay, so if you know, then maltose is a disaccharide which is formed by the two glucose units. So maltose is also known as maltobiose or malt sugar. So maltose is also known as maltose or malt sugar. So this is a disaccharide. Di means after joining two saccharides formed from two units of glucose. So disaccharide is a disaccharide. This is a disaccharide which is formed after joining two units of monosaccharides, that is glucose. And two glucose joined with an alpha 1 to 4 bond. It means that this is glucose glucose, this is galactose glucose, this is wrong. This is also glucose fructose, wrong. So now these two are glucose and glucose. And if you will see, there is not a beta linkage but there is an alpha linkage. So option C is the right option. Okay, so the next question is, so what is the hydrolysis product of this one? This is, I think, lactose. So what is the hydrolysis product of this one? Hmm. So the hydrolysis product of this one is, if you know, the first option is glucose and sucrose. The second option is glucose and galactose. Third option is galactose and fructose, and this is galactose and sucrose. So if you will see the answer, if you will do the hydrolysis of this, so these two will form. That one is glucose and the other is galactose. So after the hydrolysis of this, if we will get glucose and galactose, the option B is the right option. So we will get this structure, which is the structure of glucose, and this one, this is the structure of galactose. So these two we will get as a monosaccharide. So the glucose and galactose are the right option. So the fifth question is which of the following statement is correct? So the first option is starch is made of amylase and amylopectin. The second option is the Kiliani reaction is a carbon shortening method. The third is Coining's no reaction is the substitution reaction of glycosyl halide to form glycoside. The fourth option is acetic anhydride is not used to produce free hydroxyl group. So monosaccharide cannot be further hydrolyzed. So this is true. Monosaccharide, what we will do? If we will hydrolyze disaccharide, we will get two monosaccharides. So if monosaccharide is there, it will not be further hydrolyzed. And also starch is made of amylase and amylopectin. This also we know. And the third is the knowing no reaction is the substitution reaction, right? Of a glycosyl halide to form glycoside. So these three options are the right option. Starch is made up of amylase and amylopectin. The second is Koenig's coordination is the substitution reaction of a glycoside halide to form glycoside. And the last option is monosaccharide can't be further hydrolyzed. So these three are the right options. So moving to the last question. So this is the sixth question and this is the last question. So the last question is which of the following is not a disaccharide? So cane sugar, this is a disaccharide. Lactose, now only I told you lactose is a first is cane sugar, second is raffinose. Raffinose I will tell you. Lactose is like it we this was a lactose. This was lactose. So lactose you see this is a disaccharide of glucose and galactose. Maltose also we have seen maltose is two glucose units. Two glucose units means it is a disaccharide. So maltose is a disaccharide, so it can't be the option. Lactose is also the disaccharide, so cane sugar will not be the. So raffinose, if you will see, so this is the raffinose. Raffinose, if you will see, this is not a disaccharide. There are three monosaccharides which will come together to form one molecule of raffinose. So this is not di, but it is a trisaccharide. So raffinose is a complex sugar found in plants and whole grains. It is a white crystalline sugar made up of three simple sugar: fructose, glucose, and galactose. So raffinose is a trisaccharide, meaning it's made up of three monosaccharides: pyranose, D-glucopyranose, and D-fructopyranose. So this is not a, but this is not a disaccharide, but this is a trisaccharide. So this is a which of the following is not a disaccharide? Raffinose is not a disaccharide. So this B option is the right option. Okay, so in this assignment, six questions were there which we have discussed. I will upload these slides into the into the link, so you can go through the assignment. And also, I will upload the this recorded video on the NPTEL website. You can go through the video. So the last in the next session, whatever Tuesday, I think it will be on 9th April, if I'm not wrong. Let me check. So yeah, 9th April. So 9th April we will be discussing the class 12th assignment. That will be the class 12th. That will be class 12th and that will be the last class. So we will meet in the next class to discuss the assignment number 12th and last class. So I will upload this video along with the slides into the website. You can go through the video as well as slides. Okay. So we will meet in the next class. Okay, so
Thank you.
I am leaving the class. So if any of having doubt, you can. Sangeeta, I sorry I can't hear you.
Okay.
I can read your message.
Thank you so much.
I I was means you were I was audible, right?
Yes.
Okay, okay. So do you want to ask me something, Sangeeta?
No. No questions.
No questions from me. Okay, so shall we leave the class?
Yes.
Okay, okay. Bye, bye. Bye. Lysine and arginine both are the amino acid having basic side chain, and these are having the positively charged amino acid. It means the polylysine and polyarginine is the right option. So polylysine and polyarginine is the right option. So moving to the next question, dash is used for FMOC deprotection and dash is used for the ester deprotection. The first option is NOH and TFA, second is TFA and NOH, third is piperidine and TFA, and the fourth option is piperidine and the NOH. So if you know, this is the ester is this one. So if you want to deprotect the ester, you need a base. It means we can eliminate first and third option. Now we are left with second and fourth option. So TFA, and out of TFA and piperidine is used for FMOC deprotection and NOH is used for the ester deprotection. So the third option is the right option. So the third question is, which of the following are the peptide coupling agents? So if you will see, the options are DCC, BOP, BOC anhydride, and HBTU. So DCC, BOC anhydride is not a peptide coupling agent, but BOC anhydride is used to protect any functional group like NH2 and OH. So it is used to protect the functional group. So out of these four, DCC, BOP, and HBTU, these three are the coupling agents. So if you want to know in the like mechanism and all, you can see the mechanism for these also. So the three option DCC, BOP, and HBTU are the peptide coupling agents. So the fourth question is, the peptide coupling agents activates which group in an amino acid? The first option is amine group, second option is carboxylic group, the third option is both amine and carboxylic group. Wait, I will check if some problem is there. Now only I will come to know. I think everything is correct. So I think so. The peptide coupling agent activate the carboxylic group in an amino acid. So the right option is this one, carboxylic group. So the fifth option is, which of the following statement is true for the solid phase peptide synthesis? For the solid phase peptide synthesis is also a synthesis of long amino acid sequence. This is true. Minimized racemization, true. And also it is easy to purify, that is also true. So it means all the three statements are true. Then all of the above. All of the above are true for the solid phase peptide synthesis. So, which peptides are used in the Alzheimer? I think in Alzheimer is a disease which is related to the brain. So, peptide used in the Alzheimer are beta sheet breakers. I feel so. Beta sheet breakers are the peptide which is used in the Alzheimer. In the this assignment, only 6 question was there which I have discussed with you guys. So if you are having any doubt, please join this class. We can discuss your doubts also in this session. All in this session, so you can see these questions. For the time being, I will mute this my mic.